Welcome to the latest. Oh, no, it's just starting. Hey, welcome to the latest Elixir Roundtable. I'm Nathan. I'm a senior software engineer at Dockyard.
I'm Brian. I'm the founder of Dockyard.
Mike Ben's senior software engineer at Dockyard.
I'm Gustavo. I'm a senior software engineer at Dockyard.
Awesome. So I'm glad to have Gustavo on. He's one of the newest members of our team, and
Special guest.
Yeah, already doing some awesome work on the project that I work on, which is top secret, so I won't say what it is. But I do want to talk about something that I recently did in our project, and saw some big performance improvement that's database related. So, and I love the database, so I love talking about this stuff. So specifically, I want to talk about using things like materialized views in databases to improve performance. So I can't talk about the specifics of our project, so I'm just going to make up an example that's similar. But I did see a huge improvement from going from basically can't run this query to then being able to run it in instantaneously, basically. And this approach is leaning on the database to do what it does best, which I think fits with the Ecto philosophy. You know, we have things like uniqueness constraints and foreign key constraints. Ecto leans on Postgres in the cases that I'm using it to do that, enforce that, which only the database can do properly, and just kind of provide nice error messages around it. So let's say and you guys jump in anytime and and say anything you want to say. But so for my made up example, let's say
is this going to be summed up as it turns out the database is actually fast and the app layer is not?
Not exactly.
Okay.
The real spoiler would be don't repeat your work any more than you have to. So let's say you have a game and you need to show some kind of summary of scores, right? You have a lot of different kinds of events that can affect a player's score, and those are stored in different tables. And so to show a player's current score, you have to do a lot of joins. And if you want to get the scores for all players, you've got to do queries over the history of all events for all time. So one of the easiest and the most obvious approach is just write a big fat query and run it every single time you load the scores page. But that can look ugly in application code. But more importantly, it's just going to be really slow, and it's going to get slower the more events you have in history. So just every day you're getting more events, and it's just getting slower and slower. So another approach would be to denormalize the data. So denormalize the canonical representation of the data. So for example, shove all kinds of game events into one events table. And then you have a bunch of different columns, let's say it's a civilization style game, and you have a battle type column and a discovery type column, and some, that's going to be null on some events and filled in on other events. And that's really inefficient in space. It doesn't let you use not null constraints, so you don't really have good guarantees about what's there. It can make other kinds of queries hard. It can lead to consistency issues. We'll say you store the name of the game. If the game has a name, you store the name of the game on every event, and then oh, we need to rename the game. You got to go back to every event and change that value. So it's not a good approach to normalize that way. So another way would be to create a database view where you have a scores. It looks like a scores table, but if it's just a plain view, you can just do select score from scores where user ID equals 5 or whatever. But if it's just a plain view underneath, it's really just doing that giant query. So it's just still going to be getting slower and slower. All right, so now we're getting into oh, and there are other things like temporary tables and common table expressions that are basically the same thing. You can add indexes on a temporary table, but you're going to be setting it up on every session or every transaction. So now, the getting closer to the solution I did was a materialized view. A materialized view, you run the query ahead of time, and it stores that in a table. So you write this big query, and then you say refresh whenever you want it to refresh, and it goes back and requeries the whole history of the events and updates that table, and then you can just query from it, and it's really fast. So that's cool, except that you have to decide when you want to refresh. So if you don't refresh very often, then the data is going to be stale. If you refresh too often, then you're still incurring that performance hit all the time of requerying the whole history. And then, like, do you want to refresh on a timer? Do you want to refresh on a trigger? Or, like, there's a lot of things to figure out there and trade-offs to make. So the approach that I landed on is actually one that I got to give a shout out to. There was a blog post from back in 2015 on the HashRocket blog called Materialized View Strategies Using Postgres. It's by Jack Christensen. And it was really good and kind of helped me figure out this way of doing things. So the approach here is to basically roll your own materialized view. So the materialized view being, it's a table, it's got the end result of doing all your calculations, but a typical, just like declaring a materialized view in the database, every time you refresh it, it recalculates the whole history of everything to come up with the current scores. So this approach is you just make a plain table. You make a plain scores table. And then whenever you get a new event, you use a database trigger to recalculate just the scores for that one user. So an event comes in for one user, and you're like, oh, okay, I need to go to that user's row in that table and update it with their latest score. And that way, you never have to do that, go back through all of history and do everything again. And this is really fast at query time because it's just a table, the data's all there. The downside is that you're adding some work at insertion time. When that trigger fires, you have to do the work of calculating for that user. That's probably okay because you're just calculating for one person and not for everybody for all time. But if that turns out to be too expensive, there's a couple different things you could do. You could, instead of doing the expensive calculation right then, you could just insert like an update job and then get to that when you can. So then you got a little staleness issues maybe, but you can decide like how aggressively you want to work that job queue. It's like, trade off freshness for work. And then another option would be, it could be that calculating a single row gets slower over time. So that depends on sort of the shape of your data. If you're calculating scores per game, that's not going to be the case because the game is going to end and it won't be accumulating any more events. But if you're calculating scores for a player that takes into account their whole history, they're getting more and more events. So you could do something like have an intermediate step where you create game scores as a materialized view, and then the player scores are just summing their games. Or you could have like end of month scores that you calculate and then just like diff from the latest end of month. There's a lot of different ways you could go about that so that, again, you're not repeating too much work. All right, so I'm almost done, but just to kind of like put a bow on this. This is actually really similar. Database triggers are really similar to callbacks, which, in coming from a Ruby background with active record, I've seen active record callbacks get really nasty in some cases, like circular and horrible, and like cause really like financially bad consequences with bugs. But the way this is different, and Scott Hamilton, our colleague who was going to be on here, but he put this really nicely. He said, this is just the database keeping the database consistent. I like that way of putting it because you've got the denormalized data based on the canonical representation of the data, and the database is just making sure that those two things are consistent all the time. So that's really letting it do what it does best. It's really different from a callback like, every time I create a user, send an email. And then you're like, oh crap, what if I don't want to send that email sometimes when I create a user? And it just gets messy. So, but some similar guidelines apply to both of these things. I think keep the logic simple. Just like you would in an active record callback, try to keep it simple in a trigger, especially because DB logic is harder to debug. You don't get like stack traces and error tracking if something goes wrong. Use this sparingly. Do it only when you can prove a performance need, and try to avoid chaining triggers if you can help it, even though my last example kind of did talk about that. A whole different approach could be like stepping away from the database and caching some data in the application, but then you have like possibility of different nodes getting out of sync and stuff. So I think this is, in most cases, best to lean on the application for this kind of stuff. All right, I talked a long time. That's all I wanted to say.
I'll add to it that every time I dig into like some of the non-common things in Postgres for performance optimizations. It's always a fun engineering task to do so. Like it's always rewarding, like turning something that is slow into something fast, and the amount of ways that you can optimize the database with Postgres. I mean, it's a good reason why the role of DBA exists. I mean, there's so much that we're just exposed to on the surface level as application engineers that database administrators take for granted. It's an incredibly deep system, and it can be a bit overwhelming at times too, kind of digging into and finding these edge case performance improvements in Postgres. But that's part of the reason why I like Postgres is like how much thought and how much depth there is to it as a DB layer.
Yeah, absolutely. There's just so much there. I remember hearing about somebody who was like, I'm going to read 1 page of the Postgres manual a day. And I thought that sounds like a good idea because there's a lot in it. One thing maybe to mention also is like how I figured out what to do here was I had a really slow page and I couldn't tell exactly what was going on. And I turned on query logging. First off, I downloaded the issue didn't really come up until we were using production data. It was fine in development, but with production data, we had enough data that it was an issue. So I pulled down production data.
How large was the production database?
I don't have any numbers off the top of my head.
Like gigabytes?
Yeah, it's not really that huge, but just the complexity of the query was more the issue. There was a lot of joins, and what I found I pulled it down and then I turned on query logging in Postgres and went to the Postgres query log, and then I did an explain on that query, and Postgres was like, yeah, I'm trying to, like, with all the joins, I'm trying to do stuff with 5 quintillion rows of data, and I was like, yeah, that would be why it's slow. I didn't even know the name of that number. I had to go look it up. So, and part of that was the way the query was written. I was able to flatten it out some and make that a lot better, but it still took a couple seconds to run. So it was still too much to do in a request cycle. But I find the explain query thing in Postgres, the output is for me really hard to read, but just seeing that many rows, I knew something was very wrong, and the cost was just astronomical. So like I can't parse everything it's telling me, but I can get the big picture, and then I can run it again on a different query and say, oh, that's cheaper. So that's at least a basic tool.
I think also that it's like clever to delegate that to Postgres because they are going to do a better job than you always. So if you could delegate that and use the triggers to take something and just like, hey, whenever this happens, run that function, and you are the best at doing that. So
yeah,
I think that's awesome.
Is this one of those situations where you put in all this time and then you created this super fast query, and then the stand up next day, like you announced it, and everyone's like, that's nice, moving on to the next thing. There is like the impact of it is sometimes I find from the implementing engineer's perspective much greater than like especially management for the project. Sometimes they don't appreciate the I guess how rewarding some of those things can be.
Yeah, I think this was appreciated, but yeah, I've definitely seen that. Like sometimes things like perf improvements are sometimes they're not as splashy as a big feature. But
yeah, less money's tied directly to it.
Yeah, but ultimately they are what makes the application good, because if it's too slow, nobody wants it.
Right, it's a user experience concern.
So Mike, you have a topic I know that you want to talk about. You want to pick that up?
Sure. Yeah. Yeah, just something I've been working on the past month or two. I was actually tracing back in our Elixir chat room in Dockyard, and I think I realized Brian brought this up about 2 months ago or a month and a half ago, but just talking about COBOL and how there's so much that in our world right now that runs on COBOL still, and it's all, a lot of it's like 60 years old, some crazy amount, ATMs and banks and all that. And so I kind of had a little bit of a crazy thought, and I basically said, hypothetically, how hard would it actually be to write an Elixir app that parsed COBOL and output equivalent Elixir? Because there was talk about possibly looking at could you take COBOL and compile it down so it could run on Beam, whatever, some sort of a couple different approaches at it. But with some of the work that I've done with Credo and some other things as far as parsing languages and being able to convert to Elixir, I thought, what, may as well just take a shot at it, right? It might work, might not. And we've got Dockyard Fridays to do these sort of experimental stuff. So dove in. I've never written or seen COBOL before that conversation, but so yeah, I figured why not. So went on, watched like everything you need to know about COBOL in one video thing, and spent a couple hours watching that and like learning the basics, and how it flows, but all with a mind towards what would this look like in Elixir? What would a comparable set of code look like? What sort of issues are we going to run into? Immutability is obviously one thing that you deal with if you're writing Elixir that you don't with COBOL. So there's potentially some. I figured I'm probably going to run into something like foundational that it just won't work at all. But I figured it was worth a shot. So
in other words, Mike is now Dockyard's lead COBOL engineer, and Dockyard is accepting COBOL contracts.
No.
This is where you're supposed to say Dockyard is now a COBOL consultancy.
Yeah,
right.
Dockyard's
exactly.
now a COBOL consultant. GNU COBOL.
Yeah, no, definitely not. So here's the thing: is I realize that there could be some major fundamental thing, and I'm sure there might still be that where this just isn't even feasible. But also that if we're converting COBOL code to Elixir code, it's probably going to be like an 80-20 sort of thing. Like we can get most of the way there automated with translating stuff. But that might be a start, and that might be enough to get if there's companies or there's a lot of government organizations out there that are hoping to move off of COBOL to something more modern that they can actually find people to develop on. This might be the first step that kind of takes the edge off to try to take that first step. We can run this, and we got a set of code, and all right, let's look at what came out of it and what it actually does, and yeah. So anyway, again, very experimental. So been working on that for the past month or month and a half, and getting close to being ready to release what I have so far. I've got the basics of parsing code, and it's got a tokenizer that just goes through and makes sure that it can identify everything. A parser that takes the tokenized version and turns it into a module that has all the information that we need to then pass it on to the Elixirizer, for lack of a better term, that will take that parsed thing and write Elixir. So I have that up and running with, some of the basics, data, calling procedures, and input, output, accepting data, and writing it out to the console. And then I got a testing framework up and running. So you can, the test helpers allow you to take a section of take a COBOL text program and run it through, and it will compile it into COBOL and then run the COBOL given some inputs optionally, and give you the output of that COBOL code. And then it will run the converter, generate Elixir code, load that code into the Elixir or into the Beam on the fly, execute that code again to send inputs and get the output, and then unload it from the Beam, and then compare the output. So we can say, hey, we have this Elixir, or we have this COBOL code, run it and get the output, and then run it in Elixir and get the output, and make sure that they're the same. Yeah. So that framework's in, which I think will be super helpful in allowing us to move forward faster with the rest of the stuff. And a couple more things I want to.
I was going to say, I think it's important to note too that Mike's implementing GNU COBOL, because there's so many variants of COBOL out there, and on the complexity of this is starts to get a bit hairy when you start to also consider that some of these potential consumers of COBOL are not only using maybe a proprietary IBM version of COBOL, but also their own specialized fork of it that does specifically what they want. So like the hope is that the GNU COBOL will cover like a majority of what you'd see, and then probably there may have to be some specialized effort to cover the remainder of what's uncovered for that given project.
Right. Yeah. Yeah, definitely. And that's that might be the thing that, as far as how different the languages are, we can obviously you'd be able to modify this code to adapt to that, or we just run it and it's a best effort and we get close, and then we go and look at the output and compare it to the input and say, hey, did it get it right? And this line that our version wasn't able to understand what you meant here, go back and verify, make sure it's good. But yeah, again, like I said, very, very highly experimental stage, but hopefully I'll have that out in the next couple weeks for someone to jump in. So yeah, if you're out there and you know COBOL and Elixir, reach out. I'd love to chat and get your thoughts.
Yeah, the advantage too to potential projects for this is, the obvious one first is that COBOL engineers are becoming fewer and far between. We saw, especially around the year 2000, where everyone's like, oh, we need COBOL engineers because our system only covers like a 2-year digit rather than a two-digit year rather than a 4-digit year. But on top of that, most of these places where COBOL is installed to, a lot of the value propositions of Elixir fit naturally in those systems, right? They need a certain amount of guaranteed uptime. They need like some sort of self-healing system in place. Like these are things that governments and banks and such values of a programming language that they should be looking into and investing in. The trouble for them though is that their COBOL systems are so kind of just have been there for so long that they're trusting them to do what they do, that the cost of replacing those systems are sometimes much higher than they'd be willing to otherwise accept. So part of the idea here is that you can reduce the costs if you're just transpiling the COBOL into Elixir, and that should accelerate the rewrite to a certain degree, and also make it an iterative approach, right? Rather than just saying, hey, okay, we need someone that has the whole domain knowledge of what this system does in the room with us while we architect out the new implementation of this. So I think that there are a lot of benefits back to companies that adopt this approach. The obvious kind of issue though is that we need to find the first adopter, right? Like no one wants to be the first one. And so we're gonna probably spend some time identifying some open source projects that are built in GNU COBOL attempt those as a rewrite, because I think we found one already, or maybe I pointed you towards a chat board, the GNU COBOL group, and I think some people recommended a few. I think if we have those non-trivial open source projects that are converting over, then we have some data to work off of, right? We say, oh, we took this fairly complex COBOL program and we were able to rewrite it in Elixir like this fast. That should give us enough to go and maybe shop this around to some potential early adopters. But I'm kind of hoping that once this proves out for a few systems, then it's just really a matter of going and shopping around. That's really all it takes. It takes trust, for those type of systems in order for them to accept. So okay, maybe it's time to bite this off. The other thing with this too, with the timing of such, is that the president's infrastructure plan, the $2 trillion or $3 trillion, I don't know what the dollar amount was for the plan, but it includes massive government agency upgrades for digital systems. So there is a significant portion of that infrastructure plan that is dedicating towards potentially moving them off of these legacy COBOL systems. So if I have no idea what the state of that infrastructure plan will be after it goes through the committees and finally makes it back to Biden's desk. But presumably there will be budget in those in that plan at some point in the next year or so for this type of effort. So it could be, the timing could work out well, where if this is ready now, there's going to be receptive parties within the government for rewrites.
Yeah. A couple of things that I wanted to say. One, Mike, that's just super impressive. It's awesome that you're doing that. It's awesome that you were just like, yeah, I'll do that. And you've already got something that far. That's really cool. Another thing is, like, I know sometimes that people that are still running old systems like that are kind of the brunt of jokes, but I think we can all sympathize with, like, it's really a big deal to rewrite a system, and not wanting to pay that cost is totally understandable. And then not paying that cost for a number of years, or maybe not even having the budget to pay that cost, eventually it becomes more and more expensive. So it's a tough position to be in. So I think this is a really cool idea that could be helpful. Another thing is, if somebody happens to be listening to this who is interested in this, like has a COBOL system, why are we talking about doing this to Elixir, this crazy language that you've never heard of? So Elixir is just, Elixir is basically a nice, user-friendly, more productive shell on top of Erlang. And Erlang is long-lived, battle-tested, going back to the 80s, running telecom systems, very, very reliable. Just so somebody has that background. And one other thing that makes Elixir / the Erlang virtual machine a good fit here is, I think a lot of these systems, like if I'm specifically thinking of banks, American banking systems are kind of notorious for being like slow. You do a transaction, it's like, that transaction will show up tomorrow or whatever, and really, to modernize, you want real-time kind of features. Like, wouldn't it be awesome if every time a transaction happened, you would get a notification and you would approve or deny it? Like, fraud would be impossible. You'd be standing there at the cash register like, yes, this is me. And that kind of stuff exists in other countries. So those kinds of features, like real-time features, are just an excellent fit for the Erlang virtual machine and for Elixir. So that's why this would be a good target to convert to.
Yeah. I think that there's a lot of unrealized upside to that these systems are kind of held back by in their current, where they are technologically. So whether it's Erlang or different, more modern language, they could benefit from it. It's always a legacy industries are slow to adopt newer technologies, however, historically speaking. But again, like I said, the hope is that if we find some willing early adopters, that the success stories will speak for themselves.
Yeah, definitely. To go off of what Nathan said, that was kind of what got me. It made it click for me. Kind of got me excited about the potential here. Is that the parallels between COBOL being around forever and it just works, and trusted and all that, and Erlang, and just the been around, like you said, been around for 30 however many years now, and just the systems that run it are just rock solid, and there's a real similarity there that makes Elixir the kind of the language that makes sense to go to if you're moving from a COBOL system that still needs the COBOL benefits of that Erlang provide, and just what can we do to help that, and if we're with NX, Elixir is becoming kind of like a potential go-to for people that are doing machine learning, and maybe this will allow Elixir to become a potential go-to for people that are running COBOL systems, and just how can we help that, make Elixir more attractive to more different areas, because it is so great, and the more people that are in on it, the better.
Yeah, Elixir is also pretty unique among languages in having so many different areas where it can be useful. So machine learning is pretty new for Elixir, but also we've got a hardware platform and nerves. We've got the whole like membrane is like a streaming platform. It's like a very different domain to be in. There's a lot of different domains that it serves very well, unlike some languages that are pretty much only good for a very narrow set of applications. So if somebody were converting a system over, they could, hardware that's part of your system could also be in the same language.
It seemed like an opening to bring up my topic.
Okay.
So I was going to talk about machine learning. Just I've been following the machine learning channel. For those that don't know, there is the NX channel on the Elixir Slack, but once the machine learning group opened up on the EEF, most of the discussions moved over there. So the Erlang Ecosystem Foundation is kind of like it's not really a governing body, but it's more kind of an oversight body over all things happening in Erlang. They're kind of charged with helping promote the language, the ecosystem, and in some cases, coordinating efforts between different groups that are having similar goals, and hopefully to the point eventually where some projects will start to receive like financial support through the EF. That may already be happening in some cases, but I'm not aware of any. In any event, after Jose and Sean announced the EXLA project, the NX project rather, on I forget which podcast it was that Jose went on. Maybe Thinking Elixir. I may be speaking out of turn. Definitely not this podcast, but it was a different one. It seemed like that maybe it was already going in place, but a machine learning group opened up in the EF, and most of the conversation, like I said, moved over there. So if you're interested in kind of watching that happen, you should go onto the EF website. You apply for a membership, which is free, and then you can get access to the Slack, and it's just in the pound machine-learning channel. So a couple of things that I've noted that's going on over there is, number one, things are moving very, very fast in that space, which is really cool to see. It's really, I think it is in part due to kind of the foundations that they laid, that doing these additional feature developments have proven to happen much faster, because they have the primitives of what they've done are pretty solid. So building on top of those primitives are not like having to rework quite a bit of the library. But seeing Sean and Jose and whoever else may be involved in the conversation discuss about a potential new feature and then seeing Sean like push it a day later is pretty impressive. It's also pretty impressive to see now the amount of code that's necessary to implement some of these features, which is, I mean, these PRs end up being pretty thin, and they're adding powerful new ML features for what appears to be fairly simple implementations. Like I said, they're building upon pretty powerful foundation. But even then, it's not like NX was under development for years. Like, this is something that really started in November of last year. And yes, they are making use of the TensorFlow compiler, and so they were able to kind of skip that step of it. But I don't want to keep coming back to the Elixir fanboy discussion, but it is pretty impressive to see how in Elixir, someone that is competent in it can do the work of what usually takes teams to do in other languages, right? And so kind of outside of the compiler work for TensorFlow, all the implementation side, I mean, that was teams of people at Google implementing it. Yes, in some way they were implementing something new, and so there's the complexity involved of having novel work going on and kind of the learnings from that. And so Jose and Sean et al. Are able to kind of benefit from having that work being done already. But I mean, they're doing their own thing too. And so it's I think that's a undervalued value in Elixir, is that sometimes you don't need as large of a staff to implement something analogous as you'd be implementing elsewhere. So kind of where I want to go with the discussion though is how realistic is it for the everyday Elixir engineer to be expecting to write things, write machine learning code? And from what I've seen, I still don't think that's going to be happening. I think that having the fast calculations is definitely something that the everyday Elixir engineer can be using, so that they're not having to like go out to Rust or some sort of NIF solution, and that's great. Having this machine learning effort happening in Elixir, I'm sure, is a door opener for those that have been maybe on the edge of learning machine learning. And so now that they know Elixir, there's a machine learning option for them. Maybe they'll go ahead and be able to learn machine learning and become competent in that way. For me, though, I always tend to look at it as, okay, something becomes interesting when it becomes usable by the common developer. And like, that's what we saw for the rise of web frameworks. Web frameworks kind of made the effort of building out a web application trivial and approachable for many software developers that otherwise weren't able to do so in the past. And if you go back to early days of PHP, of Java, I mean, these frameworks, there's a reason why it was taking so long to put out a simple blog system back then, because the complexity and the kind of the nuances of languages and just the software engineering acumen that was required to do so was very high. And then comes along Rails and makes things simple and approachable, and that's why we have all this explosion in innovation and such. And so I'm still waiting for a higher level abstraction of machine learning in any language, not necessarily Elixir, that is kind of like the same aha moment for many engineers, where they're like, oh, now I don't need to learn like linear algebra and all this. I don't need to know what's going on under the hood in order to implement my own ML system. Sean is working on his own abstract layer, Axum. But from what I've seen, it's still not high level enough. It's definitely higher level than what exists in NX, but it's not high level enough where it's going to be a tool set used by the everyday software engineer. I think that you still have to have a background in machine learning in order to use it effectively. So that's kind of where I'm at. I applaud the effort on the Elixir front. I think it's a huge value add for Elixir, and it's definitely one of those things that we saw in the survey that people were saying, hey, I wish that Elixir had this, and now it's closing that gap. So it's going to be one less reason to not use Elixir. But at the same time, I still see it as being the domain of a subject matter expert in machine learning in order to be effective with Elixir NX. Thoughts?
For me, I think it's great how the ecosystem is growing, and that you have like a lot of options if you want to build some things that, as I remember at the beginning, like that was a concern. Like, okay, I could do an API with Phoenix, and that's all. And
yeah,
maybe which is the value to learn this technology or stuff like that. But I mean, it's quite impressive how the ecosystem has grown a lot, and you have a lot of tools now to use. And yeah, I think now is there is no an excuse to start using Elixir, right? In build more things.
Yeah. Like that's what's that's the definite value add of having this, because it kind of keeps people in the Elixir system. Like I've definitely seen projects that will migrate away from using Elixir over to Python just because of machine learning. Like they want to remain in that stack. They want to hire Python engineers. Well, they want to hire engineers in the language that their ML system is implemented in. And so having this kind of keeps people in the Elixir camp, and that's definitely good. And I think there's going to be a lot of really beneficial, well, I'll say side benefits to this. Like I said, the fast number crunching will be one that doesn't really require you to do any machine learning. It's just that now we have fast number crunching in Elixir. And on top of that, we have a distributed system, and so you can distribute all that work across several nodes, have them all using the TensorFlow compiler, get the fast. Actually, there's multiple compilers at this point, but you can get the fast number crunching. So that kind of defeats that argument on why not to use Elixir. Like that was a consistent one I'd always see on Hacker News over the years. Like, yeah, but it's not really good at floating point arithmetic. Like, okay, that's no longer a concern. Maybe it's still not the best, but it's like orders of magnitude better than it was before. Like, to the point where it's not worth it to rewrite in something else anymore, because that gap between where Elixir can be now and where like the top tier like number crunching is not that large. The other side of it too is I'm really hoping that it's going to start to attract more of the academic machine learning field, because like all the other machine learning implementations in other languages were kind of in the same vein as like the Python stuff, right? In many ways, they would just write their own kind of wrapper around them. They'd still send things out to Python. But with some of the ways in which the beam works, I'm hoping that this is going to catch the interest of academia for machine learning, because they're saying, oh, there's like some new possibilities for how we're doing these calculations now that we get to write on the beam rather than just writing through a normal imperative programming language. So that will be really interesting to see. Areas that I think that still need a lot of work, like their data visualization is definitely one. Like Python has, I think it's GNU plot, if I'm remembering correctly, but basically taking all your statistical data that's coming out of your ML calculations, and then being able to plot them on the graph properly. I'm not going to remember the name of it, but Jose had one library in mind. It wasn't a Elixir-based library. It was just a more modern-looking version of GNU plot, I believe, that already had Elixir bindings made for it. But I can't remember the name of it. But in any event, having more of these areas covered. I mean, we didn't even talk about Livebook either. Like Livebook's absolutely huge for that. In that alone, the amount of people I saw in Hacker News that were just blown away at number one, how quickly Livebook came out on the heels of NX, and then number two, what you can do with Livebook, because you get a lot of nice benefits from having it be running on Phoenix underneath the hood, which is you're going to get collaborative editing. You're going to get like all that code running super fast. Like if you've ever run a Jupyter notebook, sometimes the running the code itself, it's like, okay, press the button, wait, okay, now it's starting to run. And with Livebook, it's like it starts running like as soon, like before you even done pressing the button. Like it's super speedy. So kind of twofold adoption effort there, right? So you have those that are already in the Elixir space and giving them a reason to stay there because these tools now exist in Elixir, as opposed to having to go elsewhere to get those tools. And number two, chipping away at the ecosystems in other languages and offering a value prop that they don't have in certain aspects to come and check out Elixir. So I think that usually takes, you introduce something, people go, wow, but now we're going to have to wait for some early consumers of it that are going to tell their success stories, I think, to really start to see the adoption. But I'm pretty excited to see who does something with this and what it is that they can do, and have them talk about, okay, this was something that would have cost us X to do in a different language, and was so there's not just a good engineering reason, but there's a good business reason why we decided to go with the Elixir implementation. I think it's just a matter of time till we start to get those stories.
I think to go back to one of the things you said, Brian, about NX being for subject matter experts on that, but not necessarily for the average Elixir engineer. And so my immediate question is, okay, how do we bridge that? What are the ways that that your average Elixir engineer can benefit from NX? And like you said, the number crunching is one thing, but like the more things we can brainstorm on that and make, maybe there's some open source things that we need to get out there to bridge that gap between some things that people normally do. But hey, if you did it with NX, it would be better.
Well, I think there's definitely, there's an education piece as well, right? So people hear the word tensor and they're like, oh, that sounds very different from what I've ever heard before. But then you figure out that, a tensor is just like a group, like a grouping of numbers. Like it's not, it's just an array basically of numbers. It's not, it's just like engineers giving a crazy name to something. It becomes more approachable when you start to break down what the concepts are in the things that engineers are already familiar with. So I know that we had Sean do a guest blog post on Dockyard's blog for some of those basic ideas in NX. I know that Hans, I don't know if that's come out yet. Has Hans's blog post on tensors come out? Because he was doing a one as well. I should probably be paying more attention to the Dockyard blog, but I know that Hans is working on one. But I think like right now where things are, there's probably an appetite for a lot of those entry level content blog posts on just like, here are the basics. Like here's the fundamentals of what these things are. Like you don't even have to get into like, okay, how do we build out an image classifier? Like don't even need to do that yet. Like you can talk about like, okay, here's why we have a need for an outside compiler. Here's how to hook up the outside compiler. Here's how to get this running. Here's how to get that running. If you kind of give people the the foundational stuff, because that's usually the blocker, right? They try to like install something like, it doesn't work. I can't move forward. But if you not to say that the installation instructions on the projects aren't good, but I do find sometimes, especially on projects that are moving fast, these things sometimes break. Not to say that our blog posts would keep up with it, but I just think that there's something there with helping people be onboarded to it, and getting them to a point where, okay, now they're past the entry level, like here's how to get up and running. Now that I'm up and running, I can take these code examples and bring them in and start to dissect them and figure it out for myself. You know, the vocabulary, like with the term tensor, the vocabulary of machine learning is probably an important one too. Just breaking down all the terms, because there's like Jose and Sean are definitely using idiomatic like machine learning vocabulary in quite many places, and it's like, oh, I have to look this up every single time. But if there was kind of one area, if it's just like a Docker blog post, like here's all the machine learning NX vocabulary that's being used, and here's the analogous term in like pure Elixir, like tensor, array, or list. You know, here's our list of numbers, and so on and so on. It kind of makes it, it turns it from something that's like opaque into something that's approachable.
Well, I think there's that. I think there's definitely getting people more into, you know, the terminology and understanding what's going on under the hood. I guess I'm kind of thinking like, you know, for example, right now I'm working on a project that has to do with music and artists, right? And so let's say I didn't really know anything about NX, and I wanted to say to, you know, one thing that machine learning can do is come up with suggestions. You're following these people, and this is the data. Here's who you should follow. And I'm thinking like I don't want to know what the tensor is. I don't want to hear the word tensor. I don't want to hear NX. I don't want to hear any of that. I just say I've got these people that follow these artists, and I have this person that's following this artist. Who else should they follow? Like I'm thinking like dumbed down, like public API.
Oh, like a suggestion.
Yeah, right. So that's one possible way that someone who's just working on another project could use ML and use NX, but not have to know what a tensor is, you know?
Right.
And so that's basically a suggestion, some sort of suggestion, you know, black box where I throw a bunch of stuff in and get it out. So different ideas like that.
From what I understand, like a lot of that comes, so they're like on the Python side of things, there are sites out there that host pre-trained models, right? And so a lot of the I think the knowledge around how the ML system works is knowing how to go out and train your model in order to be used. But if you're importing a pre-trained model on something, maybe it's not like as perfect as you need to be for your use case, but it's going to be significantly better than any, like if you wrote just an algorithm. Bring in a pre-trained model and then putting your data through it and getting the result. That's kind of where I think a higher level abstraction might land for this. And I've talked to Sean about that. So there's kind of like two paths forward. There's one, which is, can they repurpose the pre-existing like Python or other language implemented pre-trained models that are out there? Sean thinks that they could. Like there could be an import and probably conversion process for taking in some of those pre-trained models. And second would be an ability to export your Elixir trained models and then hosting them somewhere. And I kind of suggested Hex as the obvious place, but that may not work because apparently these trained models can get very large in size, like sometimes well approaching over gigabyte if you're trying to get something like really, really fine-tuned. And I just suspect that, I mean, Hex exists because of financial support, and a lot of that's probably, just the hard drive space. So, starting to upload pre-trained models is just going to explode that. But I think that there is probably opportunity in some way where someone could do some sort of hosted, whether it's exported from Axon or maybe even some higher level abstraction at some point, like hosted pre-trained models. Because then at that point you get what you want, Mike, right? Like, so you have just like a how-to, like how to implement a suggestion engine, like write this bit of code, download this pre-trained model, plug it in, and then just, you have your API and you send your data over to it and get it out. And that's really where I think the everyday engineer wants to be ultimately, the copy paste experience, for lack of a better term.
Yeah. You're gonna get 1% of the population might actually care and dive into NX, but if you can have a suggestion model, you're going to pull in a bunch more people that maybe they weren't even thinking about doing that. But they're like, hey, Elixir, a couple lines, I can add a suggestion thing, no problem. That would bring more people in.
Yeah, one downside of a pre-trained model is it might not be relevant to your data. So on the project Mike's working on, there's a specific set of artists on this platform. So if it were suggesting artists that aren't on the platform, that wouldn't be good. So there would be some need for just like, hey, here's my data, give me some output. I think another piece is like there's coming at it from the bottom where it's like, here, learn these concepts, but coming at it from the top is like, what situations call for this kind of stuff? What kind of situations can I, as a regular developer, be on the lookout for? We're like, oh, this would be a good place to plug in NX or machine learning, because like I had a cool experience some years ago where I ran across an article on full text search in Postgres. I'm going back to databases, and I was like, oh, this looks cool, but I don't have any use for it. But I bookmarked it, And then a couple years later, I was like, oh, this is exactly the time that I need it. And I went back and I was able to implement this feature using this technique, and it was just awesome. And so just kind of having stuff on your radar of like, if I saw this kind of problem, I would go to this kind of solution.
Yeah. No, I hear what you're saying. I think ultimately being able to train your own models is going to give you the best possible outcome. I think where Mike's kind of landing though is that there needs to be some sort of like in between for those to take advantage of the power of machine learning without having to understand everything about it. And maybe there's just going to be some people that just want to get it done. Like, I need a better suggestion implementation, and what form that comes in. Maybe even then you'd have some abstract layer for even training your data, right? So if you just have someone releases their own hex library, suggestion model. It doesn't include any pre-trained data, but then it includes a way for you to actually send in your production data to train your model without, again, having to understand, what's happening under the hood. Those are some areas where I could see, the mass adoption of this stuff. Outside of like, some mega corporation, like if Discord was gonna, I see them having the depth of bench to be able to, have their own dedicated ML engineers to do, whatever in it. But where we see mass adoption of these technologies is when, a startup is able to do it and not have to, pay to bring on an ML expert, or just any other consultancy is able to start mixing these things into their offerings in some way. And that's, I think, the sweet spot where the technology wants to be.
Yeah, and without, I don't know really anything about machine learning yet, but one of the common things I see in successful abstractions is sort of the escape hatch pattern. Like, for example, in Ecto, you can write all kinds of queries using Ecto, but if you can't do what you need to do with Ecto, you can always drop down to a SQL fragment. And if you can't do what you need to do in LiveView, you can always drop to a JavaScript hook. And so that kind of pattern really works well. And so if there was something like this, what we're talking about, where just drop in my data and give me back the suggestions, if you can implement it that way, and then somebody comes on your team and is like, actually, we could tune these parameters and it would make your thing better because I'm an expert in this. As long as it gives you that way to, if you need to, you can drop into that. That would be ideal.
Like, I think that the litmus test for it is could you, could you implement this within a Phoenix Frenzy like time frame, right? So like, if no, I won't say if, when Dockyard does another Phoenix Frenzy, it'd be interesting to see if anyone's able to make use of machine learning capabilities in the future. But that would only be possible if their ability to integrate it and get something out of it is going to be relatively fast.
So are we suggesting a machine frenzy next instead of a
machine frenzy? Yeah. Well, there's I was unaware of this. It was it's an Erlang specific 48-hour competition. I wish I could remember the name of it now. Maybe Francesco tweeted it, but it was I literally just saw it last week, and I meant to stick it in the Dockyard channel. All right, this is going to be like dead air for a minute. Let me just let me see if I can find it on Francesco's Twitter stream. But I never heard of it before, and I looked it up. I guess it hasn't happened for 2 or 3 years, but it looks like it's like the 4th or 5th year of it happening, which was like, oh, how come I'm completely unaware of this contest?
The Spawnfest?
Spawnfest, yes, that's it. Spawnfest.org. So I think I saw that it was happening over multiple years, right? Where did I see that? So, I mean, it's the same. Okay, yeah. So it goes back to 2012. And it looks like they haven't done one since 2019. They had 2012, 2017, 18, 19. No. Oh, no, they did 2020. I have no idea why I never heard of this until last week. Like, it seems like it's been ongoing, and maybe when they saw Phoenix Frenzy, they're like, oh, what the hell? But it, have you guys heard? I mean, it sounds like Gustavo has heard of Spawnfest. Have you guys heard of Spawnfest before?
I've seen the name somewhere. I don't know that much about it.
So,
yeah, I'm not sure what the participation is because I'm not really seeing. Maybe in the previous years, I can see. I mean, well, this kind of seems lame. They, I don't say lame. Suspect. So they had a hardware section, and Frank was able to enter. The creator of Nerves. So that doesn't seem necessarily fair. But in any event, okay. So that also exists. But I do think that there should be probably another Phoenix Frenzy at some point.
Totally agree.
Sorry, that was like 3 minutes of me meandering to get to a very simple point.
No worries. Anybody have any final things you want to say?
I need to learn machine learning.
And COBOL.
Yeah, cool. Right. I need to work for a bank for 3 years.
All right, cool. Well, it's fun chatting. It's been fun. I can't even talk. It's been fun chatting with you guys. And let's do it again before too long.
All right.
sounds good.
See ya.
Right.